So another example, we have this problem here, and this one happens to come from the F equals MA section. So I think it's assumed that you would do F equals MA. Previous video, we did it both ways. Let's do it both ways for this one as well. So basically, this is just a projectile motion problem. Once the skier gets up here, the velocity is 25 miles per hour parallel to the surface of the ramp. And basically, it's a projectile motion problem once the skier leaves the ramp here to figure out distance d. But we've got either F equals MA, or since the skier travels a certain distance with forces acting on them up the ramp, we could use work and energy. So this one we'll do work and energy first. And so we have 1/2. Always start with the generic form of the equation, plus the integral, FDS, S1, S2 equals 1/2 mv2 squared. And now we have to think about it a little bit. V1, I think I'll fit that up here because that's not much. V1 is 1 and 2. And at 1, it's 25 miles per hour. My paper has bent a little, so it's moving every time I write on it. We multiply that times 1 hour, 3,600 seconds, and 1 mile, 5,280 feet. And it'll change it to feet per second, and that'll come out to 36.7 feet per second. That's V1. What's the mass? M. How much does the skier weigh? So when you first start doing problems like this, you'll be deterred because you're missing this. But after you have a little experience, you'll say, yay, the masses are going to cancel out. It doesn't matter whether the skier is 140 pounds, 200 pounds, or a fat old man like me, 250 pounds. The answer is going to be the same. The masses cancel out. And it actually just makes the problem easier. So those two terms, force ds. What's the distance that the skier travels? Well, square root of the sum of the squares with 8 and 20, and we'll get 2154, I think. 21.54. I don't know, it's in my head somewhere. 20 squared plus 64 square root 2154, right? So 2154. So that is the value S between points 1 and 2. What about the forces? We think the mass is going to cancel out, and V2 is what we're looking to get, and then we'll switch to projectile motion. So let's look at the forces, and if we were doing F equals MA, we'd draw a free body diagram and then a kinetic diagram. But for now, we just need to do a free body diagram. If this is the skier on the ramp is gone, right? Replaced with a normal force. And I've, we'll look at the angles in a minute. The skier has some weight, We think that M is going to cancel out, so instead of writing W, we'll label it as MG. And it says that the tow rope exerts no force once he touches the ramp. So from 1 to 2, there's no force due to the ramp. All there is the weight, right? Contrast that to, I don't know if I'll call it the previous video. I don't know exactly the order that you'll watch them in. But the previous video I made where there was a force there, and that kind of made us have to divide by M at one point. In this problem here, all we have is this. And we've got that component and that component. Right. That one makes up the normal force. The other one is what causes deceleration or does some work. It's going to be negative work, right? V2 is going to be less than V1. It's going to slow down going up that ramp. And, you know, from statics, you know, a skill that you really need to figure out is vertical is 8 and the hypotenuse is 21.54. That triangle has been switched to look like this for MG. This is the 8, this is the 20, and this is the 21.54. Right. 8 is to 21.54. Is the same as this component of weight which I'll just call F, is to this component of weight, which is mg. And so this guy right here is the shorter side of the triangle. That's going to be 8 over 21.54 mg. If you want to figure out the angle, I don't think it'll slow you down too much on this problem. It would have been mg sine of this angle here, which is the same as this angle right here. Sine would give you the opposite side, but you can do it with similar triangles. Once you've done it a few times, I don't think you need to draw that all out to see it. But that's the force going in the opposite direction. S is this, in that direction, and the force is in that direction. So we have, I'm going to do some algebra on this before I go any farther. I'm going to multiply each term times 2 to make it a little bit easier. So everything times 2, that's going to be mv1 squared. What happened to the 1/2? I multiplied it by 2. Plus 2 integral of f ds equals mv2 squared. What's the integral of f ds? Does the force change? No, it's a constant. Is the distance known? Yes, it's 21.54 feet. So I am going to plug that in, mv1 squared plus 2, and the force is negative, right there, 8 over 21.54, negative 8 over 21.54 mg, and the S is 21.54 feet, equals mv2 squared. And I just want to point out, mg is in units of newtons or pounds. This is miles per hour and feet, so I would think pounds. I'm multiplying that times 21.54 feet. I'm going to cancel that number out because there's one in the denominator along with S equal to 21.54 feet. But the 8 over 21.54 is just a percentage of mg, you know, 0.32 or something like that. And the 21.54 here has units of feet. That's the value of S. I'm going to divide each side by M, each term by M, I should say, not each side. And M goes away, as we discussed earlier. And I'm going to get V1 squared. And it's going to be minus 16 to 8 is minus 16. 21.54 cancels out. M cancels out. G equals V2 squared. That equals 36. That's my phone. That equals 36.67 or 36.7 feet per second, V1 squared, minus 16. And remember, this is, G is 32.2 feet per second squared, but I already multiplied it times feet, so it's feet squared per second squared. Running out of room there. And so V2 equals, I'll just do it out here so you can see. Calculator on. 36.7 squared. Say 1347 feet squared per second squared minus 16. No, it's not 16. 16 times 32.2 is 515 square root equals negative plus 1347 equals 831 square root 28.8 feet per second is the velocity when it comes off the net. Projectile motion, plug that in, 8 feet up, D, velocity, 28.8, direction, 8, 20, 21.54, velocity in the Y is 8 over 21.54 times 28.8. Velocity in the X is 20 over 21.54 times 28.8. Plug that into S equals S0 plus V0t plus 1/2 AT squared. And in the Y direction, so if you want, you can rewrite that in the Y. 8 or 0 equals start at 8 feet up plus, you just need the Y component, 8 over 21.54 T plus 1/2 negative 32.2 T squared. You get T is equal to a negative number and 1.11. And then this is in the Y direction. And then in the X direction, D is equal to 0, starting at the end of the ramp, right here. D is equal to 0 plus 20 over 21.54 times 28.8. T, plugging that in. That 28.8 belongs right there. And you can forget the rest because there's no acceleration in the x direction. And you get D is equal to 29.68 feet, which is the correct answer. I want to do it by F equals MA now. And I don't know. I don't think Blackboard will tell me how long the video is, but I'm trying to keep them about 10 minutes apiece, definitely under 15, and I feel like I'm already there, so I'm going to do another one.